Across AB, find the current. How many nodes are there? This is one V reference. We cannot use case KVL. Ruled out already. While seeing Thevenin's theorem, 3 milliampere is a ideal source. That's why we cannot use KVL. Ideal source is there, we cannot apply. Ideal current source is there, we cannot apply KVL. Similarly, ideal voltage source is there, you cannot apply KCL. We do not know the current. How many nodes are there? A and B are same node. A and B are at same node because short circuited. This is one node. V1 is one node. This is V2. V reference is another node. That's all. Only two nodes are there. A and B are at same node. Now what is the entire 9 milliampere is going through this. Always it prefers short circuit path. 9 milliampere is going through this already. Now write for this junction, write KCL V1 plus 12 divided by 20K. Let us assume that current is leaving the junction. That's why minus sign. 1 is over. 3 milliampere is leaving. That's why minus 3. Minus 3. This is I1. Minus I1. Minus I2. I3 plus I3 plus I3 same plus I3 equal to 0. What is current through this? A is at reference. Therefore, this is also plus V1 divided by 15K equal to 0. A also at V reference because A and B are short circuited. Now find V1. Find V1. Find V1. One variable, one equation. Three, 4 times V1. So now V1 equal to what? V1 equal to, am I correct or not? This is minus or plus? This is at V. I put the direction wrong, you know. A is at V reference. That's why the current direction must be this way. Am I correct or not? V1 is at higher potential. Here, V1 is at higher potential, we assumed. Here also, V1 is assumed as higher potential. You cannot assume the other way. So, V1 is at higher potential than V reference. Therefore, current direction must be that way. Therefore, that is also minus. So, here also minus. Why minus? Why minus? Here, we cannot assume this way because we assumed that V1 is higher than V reference. We assumed that V1 is higher than V reference. In the first case, for I1, we assumed that V1 is higher than V reference. For I3, you cannot assume that V reference is higher than V1. You understand this point? That's why we have to assume uniformly. Everywhere V1 is higher than V reference. That's why this is current direction. Therefore, minus, if you put minus sign, then what you will get? Here also you will get minus. So 7V1 equal to minus 7V1. Here 216 divided by 60K equal to 0, or 7V1 equal to 216 minus 7V1 equal to 216. Therefore, V1 equal to minus 216 divided by 7 equal to how much? How much? 30.85. Next decimal place? 86. V1 is 30.86. Where we want voltage? We need current through this. Current through this. Already we know this current, and entire 9 milliampere is going through this. That is positive. That is positive. This current, because of this minus sign, what you will get is current at V1A equal to I15K equal to what? I15K equal to minus 30.86 divided by 15K. 15K equal to how much? Equal to how much? Minus 0.57 means 6. Okay. So we got this. This current also going through this. Therefore, total current equal to I short circuit equal to IAB equal to 9 milliampere plus minus 2.06. That is equal to how much? 6.94 milliampere plus 6.94 milliampere. Now we can draw the Norton circuit. What is R Thevenin? R Thevenin is, I think, 35. 35K. R Thevenin equal to R Norton. Therefore, the same 35K can be marked here. 35K. A and B. What is the load resistance? 25K. What is the current? 6.94 ampere, milliampere. Therefore, IAB equal to I25K equal to other 6.94 multiplied by other branch resistance divided by sum of resistances. That is 60K equal to how much? 4.05